In this video, we're going to take a look at the impact of changing the learning rate and epochs on the learning of this specific neural network. All right, so we're going to start with the default setting with the layers, and we're going to leave it at the Atom Optimizer. And we're going to start with 0.001 just to find a baseline, and then we will benchmark with that. All right, let's go ahead and compile this. So real quick here, and this is something which we already know, so I'm going to run this. So as you can see here, this is 500 epochs, so it should not take much time. There you go. And let's plot this. So there you go. The MAE is pretty nice. It's almost below 1 on the 500th iteration, and it looks like there's a nice trend towards 0, or perhaps close to 0. Nice. So let's take a look at the validation loss, and validation loss somewhere between 2 and 3. Now, just to get some perspective, since we are doing so many experiments, keep in mind that during the training, of course, we are looking at the training loss, and of course, we want to use that benchmark to analyze and derive many factors. But during the actual test, the validation loss is what is going to count. So this is a metric which we are looking to understand, from which you can actually tell how your network will perform with new data. All right, so let's go ahead and see the actual numbers. So this one looks pretty nice, 3.61. Testing loss, this is what we need to know. This is around 13.4, and that's roughly about 2400 almost. All right, let's go ahead and predict it and use the function called model.predict, and you're gonna plot the values. There you go, pretty neat. And here, if you want to understand the error, and here you're converting the error in thousands of dollars. There you go. So 5 right about here is 2 counts. This can be 6, this is 4 counts, and so on. So what we're gonna do now is we are going to change the learning rate. Okay, so let's go back here. All right, so first thing is I'm going to make it really high, which is something like 0.1, so you will know immediately what this means. So let's go ahead and run this. So first compile and run. So a high learning rate means that you're going to be hitting your local minimums really fast, and of course you can overshoot it, and your network can also overtrain. All right, it's done. So let's see how this looks like. So there you go. You see it's lots of peaks and valleys, and then you see that it's going on. This is between 1 and 2, the MAE, and here is 2 and 3. So let's take a look at the actual numbers. So there you go. The training set loss is 5.4, and of course the testing loss is also pretty high at 14.88. So this is what we actually need to know. So this is 2600, so not very good. So as you can see, it's very erratic, and this learning rate does not agree with this data set. All right, let's go ahead and reduce it. So I'm gonna reduce it to, let's say, so this was the default, and I'm gonna add another 0, but that'll be making it really thin and really gradual. All right, let's go ahead and compile it, and let's go and run this. So keep in mind that there's no change to the parameters or any other factor. We're only going to change the learning rate. All right, it's done. Let's see how this one looks like. As you can see, it's very smooth, and of course it's learning. It has a nice trend. It's converging, so it's pretty good. And let's see the numbers. So there you go. The training set loss is, as of now, is 10.08, which is pretty high, and the testing set loss is 23.91, which is also pretty high. So what we're going to do is, since we chose a really small learning rate, we're going to increase the epochs, which is the iterations. We're going to give it more time for the network to learn. So let's increase this to 1000, and let's train the model. I'm not going to change anything here. Might take a bit of time, of course. comparatively much faster. There you go. Let's plot this now and see how this behaves. So as you can see, this trend is still going down, so which is good news. And if I actually print the numbers, you can see that the error is reducing, so which is a good sign. As you can see, the test loss is also reduced, and of course the training loss has also reduced. So now as you can see, there is some change in the error prediction here. So for example, the 5 now has 2.5 counts, and we have 6 which is less than 2 counts, and then we have something around 8 which has 1 count. This one about here, which is let's say -2 or 3, has 17.5 counts. All right. So now what we're going to do is we're going to further increase the epochs. Let's make it 2000. Let's run this. There you go, it's done. So let's see how this panned out, and interested to know the error. Okay, there you go. The validation loss is getting close to 2, and here we have roughly about 0.8 or maybe 0.9, which is good. Let's see the actual numbers here. As you can see, it's further reduced. So training set loss is 3.64, and you also see a proportional reduction in the testing set. Okay, so let's play this one, and let's play this one. So there you go, you see some change in the pattern. Of course, this is for this specific run. All right, now let's increase the epochs further. Let's see how that pans out. So I'm going to make a drastic improvement here, make it 4000. All right, it's done. Didn't take much long actually. Let's see how this one panned out. There you go. So as you can see here, this is a sign of overfitting. You see that these two lines are kind of going in different directions. So the training loss is reducing, but the validation loss is increasing. So now they're not in proportion. So that's a sign of overfitting. All right, so let's see the numbers here. As you can see, the training loss is 2.9, and the testing loss is actually increased to 13.27. So this is somewhere where it is missing the spot and it's going in a different direction. Of course, this could be a local minima as well. So if you want to increase it further and see how this pans out, we can do a last run, and this time we're going to make it really big one. So we're going to say go for 10,000 epochs. Of course, I am trying to open your imagination to 10,000 epochs. This is something which you can't run in all datasets. This is a smaller dataset, and we can actually afford to run it. And of course, a big thanks to Google for making this happen. All right, so let's go and train this. So this might take a bit of time, of course. So you're running this for 10,000 epochs, which is quite a number. All right, there you go. It's done. So it took a bit of time, maybe a couple of minutes, of course. Let's plot it and see how this one looks like. All right, there you go. So definitely this is going away from each other. As you can see, at 10,000, the distance is much higher compared to when they started off. All right, so let's actually see the loss here. There you go. Now the training loss is at 3, and if you can see, the mean absolute error is only 600 roughly, but the testing loss is 16.64, and almost the error is about 2800. So this is a classic example of overfitting, and by now the network actually is trying to memorize your training dataset. Great, that's really nice to see an example of overfitting.